Okay, this is section 2.5. Again, this is review material over factoring, and this is the last factoring strategy we're going to look at. So this is when we have a difference of squares. Now, we talked about this earlier, that if you were to multiply, remember, these are called conjugates. If you multiply conjugates, then you get what's called a difference of squares, because the outer is a minus AB, the inner is a plus AB, so those cancel, and that's why you do not have a middle term. So the shortcut is that you would just multiply A times A and then B times minus B to get the A squared minus B squared. Okay, so now we're going to undo this. Okay, now we're going to look to see, do we have a difference of squares? And if we do, this is going to factor so easy. Okay, so number one, first, we always look for the GCF. And I see a GCF. There's an A that's stuck in there. So I'm going to take the A out, and we're left with 36x squared minus 1. Now, do you have a difference of squares? Meaning, are both of these terms perfect squares? Is 36x squared a perfect square? Yes, it is. Is 1 a perfect square? Yes, it is. Okay, so here's the A. So that means I'm going to open up my two binomials. So what times what gets you the 36x squared? And that would have to be a 6x and a 6x. What times what gets you 1? That's a 1. Now remember, this is going to come from conjugates. So now the way that I explain this is a difference of squares. Difference means that when you factor this, your binomials are going to have different signs. One's plus, one's minus. Okay? All right. Now, here for number 2, don't panic because you have fractions. Pay close attention to what your fractions are. Is this a perfect square? Yep, it's 1 times 1. Is 4 a perfect square? Yep, 2 times 2. Is 9? 3 times 3. Is 25? 5 times 5. So we have all of those are perfect squares. No GCF, so I'm going to open up my parentheses. So what times what gives me 1/4 y squared? Well, that would have to be a 1/2 and a 1/2, and then we put the y's next to it. Now, what times what gets me 9 over 25? Well, 3 times 3, and then 5 times 5. Difference of squares means that 1 is plus, 1 is minus, and this is the factored form. Okay? So it seems a lot worse than what it is. Okay. Now, number 3. These can be tricky. So 49z to the 8th minus 225x squared. All right, so for the numbers, I know 49 is a perfect square because it's 7 times 7. 25 is a perfect square because I believe that's 15 times 15. Is that right? Yep. Okay. And then this has an x squared, so that's x times x. So it's the z to the 8th that's concerning me. Okay, well, we have to think about our exponent rules in reverse. So that means what times what would get me z to the 8th? Well, in order to get a z to the 8th, I multiply like bases, but what do their exponents have to be for me to get an 8? And I can't use 1 and 7 or 2 and 6 or 3 and 5 because if it's a perfect square, it has to be the same term. So this would have to be a z to the 4th and a z to the 4th. Okay, so it is a this is a difference of squares. So 7z to the 4th and a 7z to the 4th. This would be a 5x and a 5x. 1 is plus, 1 is minus, and that's it. Okay. All right, go ahead and try number 4 if you want. I'm going to keep going. So this is a difference of squares. So m to the fourth, n to the fourth. So that means this would have to be m squared, n squared, m squared, n squared. 16 is a perfect square, 4 and 4. One's plus, one is minus, and you would think we're done. However, this is another difference of squares. Now, I know what you're thinking. It's like, well, how come that one is a difference of squares and I can break that one apart, but this one I can't? This is a sum of squares because of the plus sign, and we can't factor a sum of squares. You can only factor a difference of squares. So that means this is going to be broken apart. Well, now m squared, n squared, that's going to come from m times n. 4 is going to come from 2 times 2. 1 is plus, 1 is minus. Now, there was a problem that we did earlier, and I don't remember where it is. I think it was in section 2. Oh, it was in section 2.3. So we were first learning about factoring by grouping, and we ended up with this x minus 5 times x squared minus 4. And I said, we're stopping here for right now, but this can actually be broken apart one more time. So it would be x minus 5 times x plus 2x minus 2. Okay, but here we were just getting used to factoring by grouping. Okay, all right. Now, number 5, using a difference of squares in grouping. Okay, so this is actually what we just did in number 4, but except it's going to be from grouping. So we're going to go ahead and cut this in half. Now I can take out an x squared, and I'm left with a y minus 4. So that means I better be left with another y minus 4 over here. And the most that I can take out of the second grouping would be a negative 25. Okay, so now I have this y minus 4, that's my GCF. And then I'm left with x squared minus 25. And so do you see how this can be broken apart one more time? The x squared minus 25 is a difference of squares. So that will be a plus and a minus. X plus 5, x minus 5. And that's it. Okay. All right. Number 6, if you want to try it on your own, you can. All right. So I'm going to take out an x squared, and I'm left with y squared minus 1. So the y squared minus 1 has to repeat. I'm going to take out a negative 4. Y squared times negative 4 gets me the negative 4y squared. Negative 1 times a negative 4 gives me a positive 4. Okay, so now we have y squared minus 1 times x squared minus 4. Wow. But look at this. Both of them is a difference of squares. And that's okay. So how do we break apart y squared minus 1? Well, y times y, 1 times 1, one's plus, one's minus. And then the x squared minus 4, that would be x times x, and 2 times 2, 1 is plus, 1 is minus. And this would be my answer. Okay? All right. Now, the last one is the sum and difference of cubes. Okay. Now, I don't ever stress that you learn the formula for how these factor because it can get really confusing, but there is a trick. Okay. So I'm just going to show you how I do it. And I do use this soap. Same, opposite, always positive, and I'll explain that in just a second. So the first thing that I want to look for is I want to know, are these perfect cubes? So I'm looking for sets of three. So what times what would get me 125? Well, that would be 5. 5 times 5 is 25 times another 5 is 125. X cubed is a perfect cube. X times X times X. 1 is a perfect cube. 1 times 1 times 1. So we're good. Okay, so here's what I do. Hang on, I got to remember what I do. Sorry. Okay, so the only thing that I'm going to remember is that when they factor, I'm going to have a binomial and a trinomial. Okay, so a binomial and then a trinomial. So here's what happens. So 125 cubed is 5x times 5x times 5x. And then 1 is 1 times 1 times 1. Okay. Now I'm going to pair these up. Okay. Now I noticed that before I paired them up, I had a set of 5x, I had a set of 5x's, and I had a set of 1s. That's my binomial. Now the box, notice you have 3 boxes and we need a trinomial. So I'm going to multiply 5x times 5x is 25x squared. 5x times 1 is just 5x. 1 times 1 is 1. Now I'm going to use SOAP, which stands for same, opposite, always positive. It's the same as your original difference of cubes. So same, opposite, always positive. And that's it. Okay. Now, number 8, again, this is going to factor into a binomial and a trinomial. All right, 8x cubed. That comes from 2x times 2x times 2x. So there's a set of 2x's times, and then 27y to the third would be 3y times 3y times 3y. So I have a set of 3y's. Now I pair these up because this is where I'm going to get my terms for the trinomial. So 2x times 2x, that's a 4x squared. 2x times 3y, that's a 6xy. 3y times 3y is a 9y squared. And then we use SOAP. Same as your cube, sum of cubes. So plus, so same, opposite, always positive. So that beats having to remember the formula. Okay. All right. Now, number 9, same thing. Don't panic. So the way you multiply fractions is top times top times top over bottom times bottom times bottom. All right. So open up our binomial and trinomial. So 1/8 x cubed would be 1/2 x times 1/2 x times 1/2 x. So that's a 1/2 x. 64, be careful, 64 is a perfect square, but we're looking for cubes. So that's actually going to be a 4 times 4 times 4, and that goes there. Okay, now we pair these up. So 1/2 x times 1/2 x. So remember, multiply fractions straight across. 1 times 1 is 1 over 2 times 2, that's 4. So this is 1/4 x squared. Well, 1/2 x times 4, half of 4 is 2. So that's just a 2x. 4 times 4 is 16. And then you use SOAP. So same as whatever you were given. So this is the plus. This is the sum of cubes. Same, opposite, always positive. And there you go. That's it. Okay. All right. Now 10. This one can be tricky, but remember, we're looking for perfect cubes. So the way that you do this is since these are exponents, if the exponent is divisible by 3, then it's a perfect cube. Okay. So this would mean x cubed times x cubed times x cubed. When you multiply like bases, you add your exponents. 3 plus 3 is 6, plus 3 is 9. Well, 9 divided by 3 is 3. So that's a perfect cube. You have 3 sets. 15 divided by 3, that would be 5. So we have a perfect set. So y to the 5th times y to the 5th times y to the 5th would give us y to the 15th. And I know 8 is a perfect cube. So there's your binomial and your trinomial. So we're going to have x cubed times x cubed times x cubed. So we have a set of x cubes. And then we have 2y to the 5th times 2y to the 5th times 2y to the 5th. Okay, now we pair these up. And x cubed times x cubed, keep your base, add your exponents, so that's a 6. This you just stick all together, 2x cubed y to the 5th. Then 4, keep your base, add your exponents, 5 plus 5 is 10. Use SOAP, same, opposite, always positive. And here's your answer, okay? That's it. All right, and then at the bottom you have your strategy. It tells you what to look for. 4 more terms you're going to factor by grouping. 3 terms. See if you have a perfect square trinomial. All right. Otherwise, you can guess. Trial and error means guessing. Or use the AC method. We did the AC method a lot. We did guess on some. If you have 2 terms, do you have a difference of squares or a sum or difference of cubes? All right. And then remember, a squared plus b squared cannot be factored. That's a sum of squares. Okay. All right, guys. That's it for this section.